Hi everyone, and welcome to this video on shading regions for inequalities. So hopefully if you've watched this video, or if you're watching this video I should say, you've done solving inequalities and on number lines. So another way of representing them is on a graph. But it's not that simple because depending on what exam board you're doing, they want a different answer. And if you're doing GCSE or FSMQ, they want the opposite answers. But as long as it's clear, I'm pretty sure that the exam board is going to give you the marks either way. So let's have a look at this first one. So x is greater than 4. So if they said shade the region described by the inequality, or they could say clearly indicate the region described by the inequality and label that region R. So there's two different ways, but let's have a look at this first one. Now, where is x greater than 4? In fact, I'm going to just change that number because these only go up to 5, so let's just change that to a 2. Now, I'm just sorry, I was just looking for the straight line. So if I draw a line on x equals 2, I'm just going to have to grab that and move it a tad because that was a pretty rubbish line. Okay. To the right hand side of that line, they're all greater than 2, and to the left hand side, they're less than 2. But we have a slight problem here, because what about on the line? Well, on the line they're not greater than 2, but how can we show that? And if we think about our number lines that we did, we had an empty circle and a coloured in circle. Well, we can't exactly make an empty line because we just wouldn't be able to see it. But what we can do is make it dashed or dotted, whatever you want to call it. I normally call it dotted. So what I personally do is I cross off the region that I don't want. Okay, so the region defined by this inequality is here. Okay, so I'm going to label it R. So in your textbooks it might colour in this region and leave this one blank and say I'm shading in the region we want, but you'll see in the next video that is not a good technique to adopt. So cross out the regions that you don't want and label the region you do want with an R. Much better advice, I think. Okay, so x is less than or equal to 3. Now you can see that the sign has changed. It doesn't matter if it's greater than or less than, but it's the equal sign. So now it is equal, we can include the values on the line. We can include x values of 3. So we want all the values that are lower than 3. So I'm going to cross off the bits I don't want, which means all of this area here I do want. Let's have a look at another one. So this time we're going to go to the y's. Now, y is greater than or equal to minus 2. So this time we're going to draw the line y equals 2. So, y equals minus 2. So here's the line y equals minus 2, and we want all the y values that are greater than. So we're going to cross off all the y values lower than minus 2. Oops. So cross off all of these. So the region we're interested in is here. Now I don't want to keep making them dotted, but less than, it should be dotted, so I'm just going to change the question so I don't have to keep doing that. So here we go. So y equals 3, and we are interested in all the y values that are lower than 3. So we're going to cross off all the ones above, and here is my region. If you're ever unsure, just take a point like 0, 0 for example. If you put a 0 in here, is 0 less than or equal to 3? Yes it is. This is the region that we're interested in. So we can take it a little bit step further with some compound inequalities. So shade or show the region, shade the region, or clearly indicate the region where the x values are between these two. And I'm just going to pop on this extra line here because it's a bit of a faff for me on this software. So we're going to draw two lines, one at x equals minus 1 and one at x equals 2. The values that we're interested in are between these. So we want to keep that bit empty and we're going to cross off the bits I don't want and put a nice big R in the middle. So if we move over to the second one, we're now looking at y equals 1 and y equals minus 4. So there's 1, and here's y equals 1, and the bottom one is y equals minus 4. And we're interested in the values in between for y. So let's take minus 2 for example. If I put a minus 2 in there, does it make sense? Minus 4 is less than or equal to minus 2, that's correct. And minus 2 is less than or equal to 1. So we can cross off the bits that we don't want. I should have gone all the way down to that line, sorry. And put a nice big R in the middle. So you can use a highlighter to cross off the bits, it's quite nice, or you could just do what I've done. So now we need to take it a little bit harder. So this is just a linear line, y equals mx plus c. So like all the others, we have to draw the line y equals 3x minus 2 first. So how do we do that? Well, this is the gradient, this is the y-intercept, and we're going to start there. So I'm going to put a little cross at minus 2. The gradient of 3 is up the ramp, and the smallest triangle to represent that gradient would be along 1 and up 3. So that's what I'm going to do. We're going to go along 1, up 3, along 1, up 3, and I could have gone along 1 and down 3 in this direction as well. So I'm going to get my line tool, and there we have it. See if I can just drag that a little bit more. It's always nice to draw your line the whole extent of your graph. So pupils normally find this much harder now. Which side of the line do I shade or cross out? Which bits do I want? Which bits don't I want? Well, I want the y values that are greater than or equal to what they are on the line. So if you take this point for example, this is where the y value is the same as 3x minus 2. It's on the line. If we go below, well, now the y values are getting smaller, so the y values are lower than they are on the line, but we want the y values higher or equal to what they are on the line. So we want the y values above the line. So we're going to cross off the bits we don't want, and this R is the bit we do want. So here's another y equals mx plus c problem. So there's c, here's m. So we start off at 1. Now a minus 2 gradient is coming down the ramp. With a gradient of 2, that would be along 1 and up 2. So let's do that, along 1, up 2, along 1 and up 2. 4 points is plenty, so just extend it all the way across. Okay, so now we want the, and I'm just going to change that. Oh, in fact I won't, I'll do it properly. There you go. So that is representing that it can't include the values on the line. So we want the y values that are lower than what they are on the line. So that is down here. Okay, these are the results we want. So we're going to cross off the bits that we don't want. Now, if you're a little bit unsure about that method, here's another one you can do. So you just test a point. Now, I would always test something with 0 in, because it's just easier to sub in. So I'm thinking 0, 0 is in, so let's test it. Remember, this is the x, this is the y, so we're saying 0 is less than 1 minus 2 zeros. Well, that's true, isn't it? Because 0 is less than 1, so this is the region that we want, so we've crossed off the correct side. Okay, so x plus y is less than or equal to 6, so we don't have to worry about the dotted line here. So you could rearrange this one for y equals. So normally we would, to draw a linear graph, we want it in the form y equals mx plus c, but these you don't need to, because it just says the x plus the y is less than or equal to 6, or if we draw x plus y is equal to 6, and then we can shade for the inequality. So if x was 0, we would have 0 plus 6, but we don't have 0, 6 here. But for example, 1 plus 5 is 6, so we could go 1, 5. The same way we could go 5 and then 1. We could go for 2 in the x and 4 in the y, that equals 6, so we could go 2, 4, and we could go 4, 2, and I think you've realised the other one is 3, 3. There are no other points on this graph, on this, well, with this scale, I should say. So let's join those up. That is the line x plus y equals 6. And what do we want? We want where it is lower than 6. So if you rearrange it like this, where the y values are lower than what they are on the line. So this is the bit we want. So we cross off. If you wanted to do a test just to make sure you've got it right, let's just test 0, 0. So we're saying 0 plus 0 must be less than or equal to 6. But that is true. So we want this area, so we cross off the bit we don't want. Now, this is the last one we're going to do, and what I would suggest is you write it in the form of y equals mx plus c. So we have 6y is less than or equal to 6 minus 2x. So now we've got the y term on its own, we just have to divide by 6 just to get y. So 1 minus 1/3 x. So we've got a y-intercept of 1, we've got a negative gradient, so it's coming down the ramp, and a third is along 3 and up 1. So let's do that. Along 3 and up 1, along 3 and down 1 for this one. So I'm going to draw the line. So I'm drawing the line y equals 1 minus a third of x. I'm just going to try and extend that all the way across. There we go. Now, when it's rearranged, it's much easier to visualize. We want the y values that are lower than what they are on the line. So the y values are lower when we go down. So we want to cross off the bit above, and this is the region we want. If you're unsure, test. You don't have to always pick 0, 0, but it's easy, isn't it? Is 2 zeros plus 6 zeros less than or equal to 6? Yes, so this is where we want them. So I'll just say it one more time. If we cross off the bits that we want, that doesn't make sense to me. And what we're going to be doing next video, we're going to have, like, say 3 of these lines, and if you cross off the bits you want, the bit you actually trying to show as your answer is going to have loads of colouring in and really be unclear. So cross off the bits you don't want and label the region you do want with an R. R for region. Okay, hopefully that's all made sense. Best of luck, and you know where I am if you need me.